Trying to get my stream manager to come up. Okay, looks like I am streaming now. All right, so I'm not streaming at my usual time. I'm streaming in the evening because I got antsy. I got to talking to a buddy about this stuff, and he was like, "Well," because I was telling him like I don't have the ability to do for loops in dataweave, and he got to saying, "Well, can you do recursion?" And I was like, "I can." And he's like, "Well, you can create for loops with recursion." And I was like, "I can." And in fact, I have tail recursion, so I can do for loops arbitrarily deep. Cool. So that means I can solve the problems where we were having big number problems with tail recursion. So offline, I worked on the prime factors and created a recursion version of that, which I'll talk about on tomorrow's stream. But today, we're going to work on the smallest multiple again, but we're going to recreate it using recursion so that it doesn't take forever to calculate the result. Or even if it does take forever, it shouldn't take forever. So, new module. We're going to call this recursion smallest multiple. And we're going to function find smallest multiple, and we're going to take a take a start and an end, right? Start is going to be a number, and an end is going to be a number, and we're going to return a number, right? Sorry about any background noise. Family's home. It is what it is. So, so here's what we're going to do. We're going to keep the same interface we had before. But now we're going to write a calculate smallest multiple. And we're going to say start. Okay, we're going to say current, which will be a number. Target, which will be a number. And result, which will be number or null. And we're going to return a number. Let's try that. See if that works. So we have read several books. Doesn't like that. So we're going to say 2 weeks ago we read. We'll just make result be 0 then, right? So we're going to say 9. What doesn't it like there? What day was that? I can find out what day that was. Probably just because I haven't input expected. Oh, because I'm not defining the function. Right, of course, duh. Result. Target is going to be, so we need actual numbers here. So we're going to do calculate smallest. So we'll say start and 0, right? And this isn't going to be this anymore.
Okay, so that's how
And
we're
now
gonna
we need to
replace it.
define that function.
Okay, so
Function,
let's say,
calculate smallest
okay,
multiple,
so we're gonna
start.
say Henry
So candidate.
and ledge.
And then remember we got the alias number.
Henry and ledge, and a careful cousin.
Yeah, and a careful cousin. Don't remember the and you can see
Who
the.
did you read with?
Oh, actually, we can just do this. We don't even need. Yeah, we do need start and end.
And
And this is
then
going to be 1,
we
right?
said
And then we can say start, end, start,
ledge.
end,
Oh,
candidate,
the
right?
black.
Equals.
The princess
The
So
black.
princess
start's
in
going to
black.
be a
We
number.
discussed a few days ago, right?
End is going to
Yeah.
be a number.
And how about
And
I get to chapter 5? Reading it
no,
over.
no, we just need this. And this is going to return a number.
Mine,
Right. Start's
Yeah.
going to be a
So
number,
let's
end's going to be a number, and this is going to just return a number. Okay.
the princess
So if
in black.
once we fill out this whole entire thing, he'll
hmm
promise us.
no, we need a candidate here.
And at the back too.
Yeah.
Candidate is
So
going to be
end,
a number, right?
start, and
And it's going to return. So if
Oh, we get a trip into a
we do need the every,
okay, let me see the shot.
so we're going to do a do here. So do
the
this.
bus.
A and
Um,
And it looks like Snowball doesn't
we're
even
going to do
have.
it inside the if. So if
Snowball doesn't have bus.
oh my gosh.
Cannon.
Bus black. Okay.
if is
Alright.
multiple,
Go put it somewhere, put it on the bar so that we know where it's at and we can write
start
our
number
right?
candidate.
How about we read 2 other
If
things?
not
Not tonight. It's 8:41. Let's get to the
Aww.
is
chapter early.
multiple, start number candidate,
Is it time for Elliot to go to bed?
then
I need to
calculate
let you
smallest
know.
To
multiple,
go take the books to your bedroom.
start,
I'm gonna
end,
these 2 books.
candidate, this should be end, candidate plus 1, right?
Else I love you forever.
Have sweet dreams,
Else
Forever Sue.
Mwah. Good night.
candidate.
Honey, have fun with Pooh.
Right.
Honey, have fun
So
with
if it is not a multiple, function is multiple, start is going to be a number, end is going to be a number, candidate is going to be a number, and it's going to return a boolean, right? And we need import every from DW core arrays. You'll notice I'm not TDDing this. It's fine. It's too late in the day for that. We're figuring out the answer. So is multiple, start, end, candidate, boolean. So is multiple. So we can steal that from here, right? Candidates every mod this. So it's going to be candidates. So it's going to be start to end. Start to end as array. We'll wrap that. Every entry candidate mod entry equals 0. think we have our answer. Okay, so let's do a unit test for this first. So we'll add a unit test. Is multiple. It should verify if every number from start to end is a multiple of the candidate. So what's an example of that? Well, we know that 25, 20, 1 to 10, right? So we can actually steal that out of here. Smallest multiple test. So 1 to 4 must equal 12, right? Of course. So if we say start is 1, and target is 4, and candidate is 12, then it must equal true. So if we run this should return true. What's going on in the news? No, I don't care about that particular news story. It verifies it returns true if every number from start to end is a multiple of the candidate. It returns false if every number from start to end is not a multiple of the candidate in do. So is multiple 1 to 4, 13 must equal to false, right? There we go. Resize that a bit. Okay, so that's good. So it returns true for 1 to 10 when the candidate is 25, 20 in do. Is multiple 1, 10, 25, 20 must equal to true. Okay. That should pass. Great. Okay, cool. So we got that. So let's write a test for calculate smallest multiple. Actually, we don't even need this function anymore. We'll just add a unit test for this. So calculate smallest multiple. It should calculate this. It should find the smallest multiple of 1 to 10 to be 2520. Actually, let's start smaller. Smallest multiple test, 1 to 4 be 12. So should calculate the 1 to 4 to be 12. And we're gonna say smallest multiple candidate number is gonna be 1. So find smallest multiple. Oh wait, yeah, I'm looking at the wrong test file, that's why. Okay. So this should be 1 to 4 with 1 as the start. And it must equal to 12. And I think we can define this candidate number equal 1, right? And that lets us have a default number, right? So then we can just do this. Let's try that. And if that's the case, we can add a default number to our start as well. We'll just leave this alone. Okay, so calculate smallest multiple 1 to 4 must equal to 12. It should find the smallest multiple of 1 to it's too late in the day for me to think. I'll just steal it from my other test. 1 to 3 to be 6. 3 to be 6. And do calculate smallest multiple 1, 3 must equal to, and this should be 9, right? No, 6. What am I thinking? 6. Idiot. It's too late. It's almost my bedtime. My code quality is tanking, but I want to solve this. So here we are. Okay. All right. So now we're going to find out if our tail recursion is written correctly, because we're going to solve this for a something higher than 256, right? So it should calculate the smallest multiple of 1 to 10 to be 2520, and do calculate smallest multiple 1, 10 must equal to 2520. This should work fine. It actually should be pretty quick. And then we know what our result is for this one. 1 to 20 should be this. So we will write that test. 399 milliseconds. Okay, we'll see. So this should, oh, need a comma. Should calculate the smallest multiple of 1 to 20 to be that, and do calculate smallest multiple 1 to 20 must equal to this. Save, run, and this should work. And we'll see how long it takes. It's going to take a lot, probably. Probably run a long time. But I bet it still takes less time than our for loop took, because as soon as it finds the answer, it's going to break out, right? So, because this one just kept going, right? Smallest multiple. First, oh well, it did first with, but it was with a huge collection and it took like 6 minutes to calculate. I'm expecting this one not to take that long. I'm expecting this one to calculate it relatively quickly. Maybe not. We'll see. I got 6 minutes till the top of the hour, and then I'm going to call it a night and get some sleep. So we'll see. 5 minutes. But we solved it with recursion, I think. We'll know when the test passes or fails. So, but we didn't hit our stack too deep. So we wrote our tail recursion correctly. So for those who don't know that, about that, we can look here at, yeah. So when you recurse in dataweave, you want to recurse in your if statements, right? And then you want your else to just return the result. And if you just have it return that one thing, then it'll treat it as something that it can tail recurse over. And so it'll just keep going. If you don't write it this way with this structure, it'll only recurse 256 times. Yeah. And then it blows up. But this should work. I'm bummed that it didn't take less than a minute. I was hoping by doing it this way we might hit our because we've basically optimized our code instead of relying on dataweave optimizing the iterations for us. I don't know. I'll see how long it takes to calculate it, and if it takes longer than I think it was 6 minutes that it took earlier today, then yeah, I'm gonna wait it out.
Okay.
Um,
Okay. Oh, I forgot. I didn't hit the.
there are ways we could optimize this, but I don't know.
Heather knows as far as that. Yeah, it's having a lot of trouble with it.
We could add our start number here to be something high if we know it's a high number, right?
So
Um,
they are this family on TLC that had 19 kids.
yeah, that would work.
That is
So
a part of a cult.
interesting. I wonder if because we have an optional argument there, if we set our start number to some arbitrarily high amount, like we know it's not going to be below this, right? Because we do know that. We could speed up our time considerably. I'm going to let this run. It feels like cheating to start from some arbitrarily high number, though. So like this is 1, 2, 3, 4, 5, 6, 7, 8. So this is 200 million, right? So if we threw away like the first 100 million, it would like almost cut the time in half, right? Um, but we have no arbitrary, like that would be arbitrary. We have no way of knowing conceptually that it's below some threshold, right? Because why would we? So um, we could know that it's above 2520, but that really cuts off like almost nothing. I do like that we got this down to 9 milliseconds and this down to 14 milliseconds, this down to 342. That still feels faster than what we were doing earlier today. But we are at 7 minutes. No, 6 minutes. And we still haven't calculated, over 6 minutes, and still haven't calculated the result. So that's a bummer. I bet my poor computer is working hard right now too. Let's get my activity monitor out and look. Mm, yep, it's working. Let's look at my CPU. Yeah, I have a Java process that is chugging away at my CPU. That's another thing is I reached out to the on the dataweave Slack channel, MuleSoft's dataweave Slack channel, and was like, hey, is there any way to do this stuff in parallel? And they were like, no, it just doesn't work that way in dataweave, which I kind of knew already, but I thought I would ask. So, all right. Well, we're at the top of the hour. I'm gonna call it. I'm gonna let this keep running. I'll let folks know in the morning what the time, how many milliseconds it took for the test to complete. But yep. So later.